All right, Daniel, in this second recording, I'm going to go through trigonometry for you. So starting with chapter 12a, review of the basic trigonometric ratios. So the basic one is the SO, CA, and TOA method, right? So what does SO means? Well, SO means sine of an angle, right? Sine theta would be opposite over hypotenuse. O is opposite, H is hypotenuse. And CA means cos, so C stands for cos, so cos of an angle is adjacent over hypotenuse, and then tangent of an angle would be opposite over adjacent. So how do we apply this? Let's say if you have a triangle that looks something like this, right? It's a right angled triangle, and remember the SOHCAHTOA is only for right angled triangle. Right angled triangle. Okay, and then if you have the sides 12, 13, and 5, and this angle here is theta. How do we find theta? You can do it either way, but let's say we were trying to find the sine, cos, and value of theta. All right, so sine theta, cos theta, and tangent of theta. So if this is theta, the way to see like the opposite and adjacent is this. Adjacent is the side that is literally adjacent to the angle, right? So this is the adjacent side, okay? And then the angle, think of it as like an eye, it's looking forward. Then the side opposite of that, literally opposite of that, is the opposite side. And the hypotenuse is always going to be the one that's the longest in the right angled triangle. So sine of theta is opposite over hypotenuse, which is 12 over 13. Cos of theta is adjacent over hypotenuse, and that would be 5 over 13. And tangent theta is opposite over adjacent, which is 12 over 5. Okay, and then you can actually use these concepts to solve for the side as well. So to solve for the angle as well. So let's say if we have another triangle here, and then theta, so theta, and then 6 centimeters, 11 centimeters. So when you look at this triangle here, in order to solve for the angle theta, you need to know this side, and that's opposite. This one is the hypotenuse, so that's opposite, and this is hypotenuse. Which rule has O and H? That's the SO rule. All right, so we're using sine of, so this one you actually need to use sine of theta is opposite over hypotenuse. All right, so sine theta is opposite over hypotenuse, and that would be 6 over 11. Then to find the angle theta, note that this is sine of theta equals to a certain value. So the angle theta is inverse sine, right, of that value. And when you punch it into the calculator, the answer will be 33.0557 degrees. Right, so the angle is 33.0557 degrees, or to one decimal place would be 33.1 degrees. Okay, so this is the triangle that you need to use the sine rule to solve for the angle. Sometimes you will need to use a different rule. So for example, let's say same angle theta here, but then we have this side is 5, right? Let's say this one is 7 and this one would be 12. So now let's see what side do we have here. Not the hypotenuse. Now this side is the opposite side, right? And then this side is the non-hypotenuse adjacent to the angle, so that's the adjacent side. Which one has O and A? That's a TOA rule. That means we're going to use tangent of theta is equals to opposite over adjacent, would be 7 over 12. And so theta, which is the inverse tangent of 7 over 12. And then the answer in one decimal place should be 30.3 degrees. Right, so that was the end of chapter 12a, just revising these basic concepts. Now, chapter 12b is about exact angles. Now, in chapter 12b, the exact angles are actually derived from two triangles. And the two triangles, one of them is an equilateral triangle, and the other one is an isosceles triangle. Okay, so the textbook actually gives you the table, but I want you to practice seeing from the two triangles here. So equilateral triangle is a triangle where the three sides are the same, so I'll draw that one first. And then isosceles, now this is a special one. This is an isosceles right triangle. Okay, so isosceles right triangle, which means that the two sides that are not the hypotenuse will be the same, and then the hypotenuse will just be here, and it's a right angled triangle. So for the isosceles, just remember you need to draw down the line in the middle, and in an equilateral triangle. In the equilateral triangle, the angles are all 60 degrees, right? So this one would be 60 degrees, and because it's an equilateral triangle, because of the symmetry property, each of these two angles are the same, and they're just half of the 60-degree angle, so that's 30 degrees. Now, what are the sides of this equilateral triangle? Now, because of symmetry again, these two sides are the same, and it's half of the longer side here. All right, so to make the numbers easy, I'll make the longer side 2, which means the shorter side here would just have the value of 1. All right, so this short side has a value of 1. How do we calculate the that side here? So if we were just to work out very quickly, that's x, right? And then using the Pythagoras theorem, you get x squared plus 1 squared equals 2 squared. So then you got x squared plus 1 equals 4. So x squared equals to 3. And we want the positive value only because that's the side of a triangle, which means x would be square root 3. So that side will always be square root 3. Then, based on this equilateral triangle, let me move this stuff here to the side. All right. Based on this equilateral triangle, you can actually read off sine, cos, and tangent of these angles here. So, for example, sine 60 degrees is opposite over hypotenuse. All right. So, opposite of 60 degrees is the side here. So, that's square root 3 over hypotenuse, which is 2. Okay, and let's say cos of 60 degrees would be adjacent over hypotenuse. So adjacent of 60 degrees is the side here, which is 1. And so that would be 1 over hypotenuse, which would be 2. And how about tangent? Let's try tangent of 30 degrees. Now note that 30 degrees is this angle here. So opposite side would be this one. All right, so tangent is opposite over adjacent. Opposite is 1. Adjacent will be this side here, which is square root 3. Right, so that's how you use this triangle to get the exact values of certain angles. And the two special angles are 30 degrees and 60 degrees for the equilateral one. Now moving on to the isosceles one. Again, isosceles means these two sides are the same, and to make them simple, I would just say this value each side is 1. And then using Pythagoras theorem, let's say that side is x, you get 1 squared plus 1 squared equals x squared. Okay, so that'll be 2 equals to x squared, so x would just be square root 2. So the hypotenuse will be square root of 2. And because it's an isosceles triangle and the one here is 90 degrees, these two angles will be half of that, and they'll be equal to each other, which is 45 degrees. Then that means that this triangle is used to read off sine, cos, and tangent of 45 degrees. So sine of 45 degrees, right? Doesn't matter which one you look at. Let's say we look at this one here. So opposite is 1 over hypotenuse square root 2. And then cos of 45 degrees will be the same because adjacent here is also 1 over square root 2. Now tangent of 45 degrees though would be opposite over adjacent. So that'll be 1 over 1, which is just 1. So that's how you read off the exact values of these using these special triangles here. So once again, recap for that. One is an equilateral triangle. You should need to practice drawing these ones. And the other one is a right angled triangle. Okay. Equilateral one means all 3 sides are the same. And I want to split this one into 1 and 1 so that the other side would be 2. Using Pythagoras theorem, I get this one to be square root 3. Equilateral means the angles are all 60 degrees. And the top one is half of the 60 degrees. So that's just 30 degrees. And you can read off of it using SO, KA, and TOA to get sine, cos, and tangent of these special angles, which are 30 degrees and 60 degrees. Now for the isosceles one, the 2 sides are the same, right? And we assign the value 1 to each so that the hypotenuse is square root 2. Then the angles, because they are isosceles and right triangle, the angles are just 45 degrees. They're both 45 degrees. And same thing, SOHCAHTOA, TOA, you can read off sine, cos, and tangent of 45 degrees using that triangle there. You should try to fill in this table where the angle is over here, 35 degrees, 60 degrees, and then 45 degrees. And see if you can find sine of the angle, right? Sine, cos of that angle, and tangent of that angle. Fill in that table, compare with the textbook, and see if you get the right answer. Okay, so Daniel, I'll just go through 12A and B for now. All right, please go back and try the exercises and see if it makes sense. If you want, you can try out, 12A and 12B. So if you want, you can try out 12C as well, three-dimensional trigonometry. The idea is that you need to resolve them into right-angled triangles. But 12A and 12B is the first two chapters to revise on these concepts here. Sokatoa.